After example 4, we will go to the next section, talking about the saturated liquid vapor mixture. Okay. In the previous sections, I've talked about how to find out the saturated liquid and the vapor states. Okay. But in reality, most of the cases we will encounter should be in a mixture form. For this saturated liquid vapor mixture, it refers to the case that saturated liquid or vapor will exist on the curve. Okay. That means inside a container, there will be saturated liquid as well as saturated vapor, and it coexists below this curve. Okay. For example, I have a saturation dome. Okay. At this point, directly, then we will have a saturated liquid. At the right-hand side, we will get a saturated vapor. But in between, that means inside this saturation dome, we will have a saturated liquid vapor mixture. Okay. And on the next slide, I will talk about some definition. But before I will talk about those definitions, let me talk more about why we need to define the things in the next slide. Okay. So, for example, I would like to determine the specific volume or the average specific volume of that saturated liquid vapor mixture. Okay, how? First of all, how do we find out the total volume inside a saturated liquid vapor mixture? Well, you can decompose it into two parts because we know that saturated liquid and vapor coexist inside this mixture. So we can divide it into two parts. One part is the volume that is occupied by the saturated liquid. So we'll have VF. And another part is occupied by the saturated vapor. So we will have V equal to VF plus VG. Okay. After that, let us rewrite it in terms of a specific volume. Okay. So this VF is the volume occupied by the saturated liquid. So we can write it to be MFVF. Okay. Note that this V is in a small letter. This is capital letter. And this MF stands for the mass of the saturated liquid inside this mixture. Okay. Similarly for the vapor, same thing. How about this big V? This big V, we can rewrite it to be the total mass multiplied by the, you can say that this is the average specific volume. Okay. Then of course we can just divide both sides by this M to obtain this specific volume. But note that this mass actually can be decomposed into MF plus mg. Okay? Because we know that the total mass of this mixture is equal to the mass contributed by the saturated liquid part as well as the saturated vapor part. So we can substitute M equal to MF plus mg. And this one is the V average. We can rewrite it to be MF divided by M total. Okay. So this M total is just the M here, but I just use another symbol. Okay, you know what I mean. So VF plus mg divided by M total Vg. Okay. So this part, because we know that the total mass is equal to MF plus mg, so this MF is equal to M total minus mg, or we can rewrite it to be 1 minus mg divided by M total VF plus mg divided by M total Vg. Okay. If we expand this part, expand these brackets, you can see that this VF and Vg have a common factor, mg divided by M total. And we will have the VF multiply here. So we can rewrite it a little bit to become VF plus mg divided by M total Vg minus VF. Okay. So we just expand these brackets. So it becomes VF minus mg VF divided by M total plus mg Vg divided by M total. And we just take a common factor. Okay. So here, this Vg minus Vf, as I've defined before, this is equal to VFG. So I will write it to be, we also define one more thing. We define this portion, this fraction, mg divided by M total to be x. So this x is equal to mg divided by M total. Okay. So we have derived this expression. This V average is equal to VF plus XVFG. Okay, usually we will give a name to this X to be the quality. Okay. It is the ratio of the mass of vapor to the total mass. So we'll have M vapor divided by M total, or mg divided by m total. And we can also rewrite it to become x equal to v average minus vf divided by vfg, okay? Because we know that v average equal to vf plus x vfg. You just put this vf to the left-hand side and divide both sides by vfg to get the x. Okay? So if x is equal to 0, that means there is no any vapor inside this mixture. That means it is a saturated liquid. If this x is equal to 1, that means the mass of the vapor is equal to the mass total. It means that the total mixture just consists of saturated vapor. Okay? Okay, and note that one thing, m total equal to mf plus mg. Okay, we have derived this, that's the average specific volume. Okay, using similar argument, okay, we just replace the small letter v to become small letter u and small letter h respectively. Then we can also get these two formula. Okay, these two formula help us to find out the average specific internal energy and the average specific enthalpy of this saturated liquid mixture. Okay. Okay, this diagram shows geometrically how we can find out the quality. Okay, x is equal to the length of AB divided by the length of AC. What is V average minus VF? Because this horizontal axis is V, so this V average minus VF is just the length here. V average minus VF is the length here. While this VFG, as we have defined before, is equal to VG minus VF. So VG minus VF is just the length of this. So we can geometrically find out the quality here. I will show you in the next few examples to show how we can use the formula we have developed to solve the problems.